Hello, look, my name's Roy Murray Pryor and I'm talking to you from lands of the Bundaburra Yiddi of the Yidinji tribe in far north Queensland. And I'd like to pay my respects to their elders past and present. I'm going to be talking to you today about some of the issues associated with using behavioural science theory when promoting behaviour change for practices in the smallholder farming systems of the East Ganges Plains. And my colleagues who are also associated with this presentation are Faye Roller-Roopson from the University of Western Australia, Renee Villano from University of New England, and John Mark Sarmiento from the University of the Philippines, Mindanao. Our project is in, ACR project is in 5 locations in the Eastern Gangetic Plains in Purnia district of Bihar in India, in Cooch Behar and Malda districts of West Bengal in India, in Sunsari district of Nepal, in Rajshahi district of Bangladesh, and in Rangpur and Dinajpur districts of Bangladesh. In our project, we're applying behavioural science insights to enhance the adoption of conservation, agricultural and sustainable intensification technologies. And in this paper, we will be talking about some of the issues associated with integrating behavioural science insights with traditional extension theory and practice and how we might test their benefits. To give you a bit of background, the Eastern Gangetic Plains are in the eastern side of South Asia on the Indian subcontinent. And smallholder farms in this area are normally around 1 hectare or less. And they are amongst the poorest farmers in the world. And there are over 300 million people living in this area. The cropping systems are mainly rice-based, with rice mostly grown during the monsoon season, but in other seasons. And then during the drier seasons, mostly, we have maize, wheat, mustard, kidney bean, mung bean, and other crops. And farmers will have up to 2 to 3 crops per year, with Bangladesh being more likely to have a higher number of crops. However, yields can be low, as shown by the wheat yields, which average between 1.5 to 2.5 tonnes. What we're talking about with conservation agricultural innovations are the use of different technologies associated with unpuddled rice, rice planting using rice transplanters, and also zero-till machines for planting dry season rice and also planting other crops mostly during the winter season, but also during the early summer season. Now in Bangladesh, because they only have 2-wheel drive tractors, the system for zero-till is more like strip-till, and the 2-wheel drive tractor has a power tiller on which is mounted a seeder. And most of the tines are removed from the tiller, leaving 2 tines in front of where the seed is planted. In India and Nepal, they have four-wheel tractors, and most of the zero-till crop planters are pulled behind a 40 to 50 horsepower tractor, and they're mounted on the 3-point linkage. And they have a seed, plant seed and fertilizer, with the seed part being able to handle seeds from small sizes up to larger sizes like maize. One of the issues in these areas also is levelling the land, so an associated technology is laser land levelers. What we're looking at is how we might apply the behavioural science principles arising from psychology, sociology and economic theories, which include everything from the early behaviour theories through prospect theory and dual systems theory, which were developed by Kahneman and Tversky, social cognitive theory, the theory of planned behaviour, and the social identity approach, which incorporates a couple of theories, and nudge theory developed by economists mostly. And in testing the interventions based on these theories, the approach used is mostly to use randomised control trials. Now, randomised control trials have a series of advantages, and they're regarded as the gold standard for program evaluation. And what happens, and you may have heard about this in medical research, is that individuals are randomised into control and treatment groups. And the advantage of this approach is that you can establish causal links between the interventions and the outcomes. In other words, establish whether the intervention is leading to a particular outcome. You can also establish causal economic and psychological processes which may be driving those outcomes by using different designs. And the other advantage is because if you've got an expensive intervention, it's important to establish the effectiveness of the intervention. Does it work or not? And is it statistically significant? Another advantage of using randomised controlled trials is it enables academics in particular to develop theory and publish highly ranked academic papers. It also means that the researchers have to be involved with people in the field, particularly in agriculture, and this provides context and perspective and empathy for the issues associated with the people, the farmers they're dealing with. However, there are some concerns with it. Obviously, if it's a gold standard, it sometimes involves the expenditure of a lot of gold, and we need to consider what the opportunity cost of this is. And it often doesn't help us answer the big questions. Now, a lot of the randomised control and behavioural science research is answering relatively small changes. There's also a conflict between the goals of randomised control design. You can either have narrowly defined treatments and outcomes so that you can establish a significant difference, or you can design the research to establish causal economic and psychological processes, or you can design it to have a more complex and multifaceted treatments to achieve outcomes that have real impact. For academics, the first two of these are the most important. But for farmers and extension officers, 3 is critical. So what is the best use of scarce resources? I would argue that it's the effect size, stupid, which is most important. Other dilemmas with using randomised control trials, particularly to measure CARSI adoption, is that these technologies are complex. They involve service providers who must own either a rice transplanter or a zero-till or a strip-till machine. They have to have the machinery to drive that machine. They have to have the experience and be good operators of that machine. They have to deal with farmers, and you have to get farmers to adopt it. So you've got to get service providers and farmers to be adopting the technology, as well as input providers who will support it. And you need to have practical economic and social benefits as a core goal. So what should we focus on with our design? Should we focus on a particular factor and why, or should we focus on achieving change? What statistical power do we need for the design? One of the issues with low power designs is you may miss detection, particularly if the difference is small. But then also you may overestimate the effect size, once again, particularly if the difference is small. But small effects for CARSI are of little value. So we're not really interested in establishing change that doesn't make much difference to adoption. There are other critics associated with context, selection bias, and scaling issues. So to design problems for us when measuring CARSI adoption is that we can't randomise by household, mainly because of spillover effects. If you think about households in a village, everyone talks to everybody else and knows everybody else's business. So if you can't run a demonstration and a training or give messages to people, which will only be accessed by the participants. We could randomise by village if the village was sufficiently separated. It's one way of overcoming that issue. The other problem is we can't use double-blind or single-blind designs for obvious reasons, because both the participants and experimenters know what's going on. And even the data collectors and analysers will know, because they will know from the types of questions and answers that they get from the various participants. Another issue is some people regard it as unethical if we have an intervention that works, but we don't give it to the control. Some researchers use the excuse that they're uncertain about the outcomes before the trial. And to be honest, in a lot of our work, we are, to a degree, uncertain about the outcomes we'll achieve. Some economists often ignore or argue against using this principle. The other issue is that control groups are not receiving the direct, real or perceived benefits, but intervention groups receive the hypothesised benefits. And this can create longer term problems. Anybody involved in it, because they have to have a survey to be as part of the randomised control design, creates expectations about something. And extension officers are always loath to involve farmers in something if they're not going to get a benefit. And I have had experience of control participants being angry and refusing to cooperate with later projects where they have not received any benefit from their involvement earlier. So what are our options? Well, one option is to randomise at the village level, not at the household level. So within treatment villages, of course, we may randomly select households to get some interventions, for example, text messages, or we may allow all people to come along to a training exercise, and some farmers will come and some farmers won't come. We also need to ensure sufficient distances between villages for different treatments to reduce spillover effects. But the issue is we also need villages that are similar, not too different, to enable us to be able to detect statistical significance. And another way of overcoming the issue, or at least dealing with the issue of spillover effects, is to conduct random sampling of treatment and non-treatment households from a village, so that we get both those who attended the intervention and those who didn't, to assess spillover effects. One of the options for the control problem, this depends on context. This control problem is control villages not receiving anything in some approaches to this, is for the control villages to receive a standard extension content, and the intervention or treatment villages receive the standard extension content plus the BSI enhanced treatments. In the next year, the control villages would receive the BSI improvements if they are proved beneficial. The other way of doing it is initially design interventions to achieve practical economic and social benefits. In other words, not just being about trying to achieve statistical significance, although this is important. We want larger statistically significant differences. And the other way is, if we find we're getting a benefit, then later we may investigate factors driving that change or the underlying behavioural explanation for why that's occurred. Other suggestions is when we're designing BSI interventions, that they can be used to help scaling of relevant innovations. And for smallholder farmers in developing countries, it is difficult to design, particularly if you're using randomised control trials. And we have to seriously consider the trade-offs with the various designs and focus on designs that provide the maximum benefits for the maximum number and minimise the control group problem. Thank you.